Hello, my name is Rebecca Muller. During today's lesson, we're going to consider how linear functions can be used in application problems. Let's look at our first example now. The following formula gives the surface area of a cylinder in terms of its radius and height. Solve this formula for the variable h. Notice that what we're given is sometimes called a literal equation. It's a formula for surface area. The variable h is here in this term, but notice we have other terms that involve other variables also. We're going to begin by trying to isolate the term by subtracting 2 pi r squared, that is, from both sides of the equation. We end up with s minus 2 pi r squared equals 2 pi r times h. I emphasize the fact that what's going on between the h and the other values, that is, in the term, is multiplication, because we know that in order to undo multiplication, we end up using division. Therefore, we're going to divide both sides of the equation by 2 pi r in order to get our final value for h. We can then write s minus 2 pi r squared divided by 2 pi r equals h. And we've solved this linear equation for h. The next examples we're going to consider are what are normally called word problems. And in order to solve these word problems, we're going to use a four-step process called Polya's four-step problem-solving process. And this is basically a logical means of going through a problem. First, we want to understand what the problem is asking us to do. Next, we want to devise a plan in order to solve the problem. Third, we carry out the plan. And finally, we need to remember that once we've gotten a solution, we want to look back and make sure that that solution makes sense in our problem. As our first problem situation, we want to look at the dimensions of an aquarium, given as follows. The front of a rectangular aquarium has a ratio of its length to its width of 5:3. The perimeter of the rectangle is 64 inches. Find the length and width of the rectangle. In order to solve this problem, what we want to consider are what we should have allowed the variables to equal. Let's begin by identifying our unknowns. We know that we're trying to find the width and the length of this rectangle. We're told that the ratio of the length to the width is 5:3. If we let the value for the width equal x, then our length ends up being 5/3 x. That's how we write down the ratio as 5:3. Next, we're told that the perimeter is equal to 64 inches. Recalling a formula from geometry, we have that the perimeter of a rectangle is 2L plus 2W. We can substitute then for P as 64, and L, we're using the setup that we have at the top of the screen, 5/3 x. And for W, we chose the variable x. Now, simplifying, 64 equals 10/3 x plus 2x. 64 is going to equal 10/3 plus 2 is the same as 6/3. So what we have is 16/3 x. And next, we're going to multiply both sides of the equation by 3/16. What that will end up doing is to multiply by the reciprocal value in order to end up getting a coefficient of 1 for x, and we come up with 16 goes into 64 4 times, 12 equals x. Let's remember that x is the width, the length was 5/3 times x, so this is going to be 5/3 times 12, and 5/3 times 12 goes, 3 goes into 12 4 times, we come up with a length of 20. So using the values, the units that we were given in the problem, we have a perimeter of 64 when we have a width of 12 and a length of 20. Our second example is going to work with a problem called a mixture problem. And here we're going to be considering what happens when we're trying to mix pure acid to some percentages in order to come up with a higher percentage or strengthening of our solution. Here's the problem. Acid mixture. How much pure acid should be added to 6 liters of 30% acid to increase the concentration to 50% acid? In this problem, we're trying to find out how much pure acid we have. In order to figure that out, we're going to have to use the percentages that were given. Let's begin by identifying what we're trying to find. Here we want to let x equal the amount of pure acid. We're told that we have 6 liters of 30% solution. In order to use that in our equation, what we can write down is that 30% of 6 liters will be added to the pure acid. Now, we know that we have X amount of it, but the percentage that we're going to have to use is 100% because pure acid is 100% acid. So we can write that down in decimal form as 1 times X. And finally, we want to end up with 50% acid solution. So we have 50%, but we also have to know what amount we're dealing with. Here we have 6 liters, here we have X liters, so adding those together we get 6 plus X as our amount. In order to simplify matters, I'm going to multiply both sides of this equation by 100. That will give us 30 times 6 plus 100X equals 50 times 6 plus X. Now we can multiply out in order to simplify the equation and solve for X. Multiplying 30 times 6 gives 180 plus 100X equals, distributive property here gives us 300 plus 50X. We can subtract 50X from both sides of the equation and get 100X minus 50X is 50X. And we'll also at the same time subtract 180 from both sides of the equation. 300 minus 180 is going to give us 120. So we have 5X equals 120. Dividing both sides of the equation then by 50 gives us a value of 2.4. Now we're going to verify these results by looking at the graphs on the graphing calculator. We will input the left-hand side of the equation into y sub 1 and the right-hand side of the equation into y sub 2. Y sub 1 will end up equaling 0.3 times 6 plus X. Y sub 2 will end up equaling 0.5 times 6 plus X. I'll go to a standard viewing window. There's the left-hand side of the equation. There's the right-hand side of the equation. We'll be looking for the point of intersection. Second, calculate the intersection point. Y1 is our first equation, Y2 is our second equation, and we can move over to what looks like the intersection point and press enter. And notice that we end up with the value of 2.4 as we had found it in the problem. What this means is that in order to end up with a mixture as we wanted, we have to add 2.4 liters of pure acid. Now, we will also have an application in linear equations called direct variation, and that's what we're going to consider next.